Yeah, students, good morning to all of you. This is another topic we are coming today with, that is uniformly accelerated motion. Till yesterday, we were talking about uniform motion. In uniform motion, the body moves with uniform velocity. That means the velocity is constant and the body moves in a straight line. That is, generally, it is called linear motion. So today also we are talking about the motion, linear motion only. But yesterday's linear motion with uniform velocity. Today we are discussing uniform motion with uniform acceleration, right? Uniform acceleration means all along the journey of the body, the acceleration of the body remains a constant. Yesterday's topic, all along the motion of the body, the velocity was constant. Today, the body moves in a straight line, but its acceleration always remains a constant. Acceleration remains a constant means the change in velocity, the change in the amount of velocity in unit time is a constant. It can increase or it can decrease. When the velocity is increasing with a constant rate at every unit time, this is called acceleration. If the velocity of the body is decreasing with a constant rate per unit time, then it is called uniform retardation, right? So it's acceleration is defined as the change in velocity by time. When a body moves in a straight line and its velocity is going on changing, it is increasing or decreasing. The change in velocity by time is called acceleration. If it is positive, it is increasing, it is acceleration. If it is decreasing, it is called retardation. Sometimes it is also called as deceleration, right? So acceleration is denoted by the letter A. So acceleration A is equal to what? Change in velocity. Change in velocity divided by time. So simply we can write B by T, we can write. Okay. So this is the condition. So in uniform acceleration, the acceleration of a body always remains a constant. Acceleration is equal to velocity by time. Sometimes it is defined as rate of change of velocity is called acceleration. Right? Okay. It is a vector quantity and its unit in the SI system is meter per second square. Unit. Vector quantity. Unit is equal to meter per second square. Always remember this. Unit of acceleration is meter per second square. Right? So its dimensions are dimensions. Dimensions are m raised to 0, l raised to 1, t raised to minus 2. This is also important. So every physical quantity, you must know the dimension also, right? So this is what is called acceleration. So if the velocity changes with unequal amounts in equal intervals of time, this situation is called variable acceleration. Motion of the body is with variable acceleration. So the body can move the uniform acceleration, also can move with the variable acceleration. When its variable acceleration takes place, body moves in a straight line, but the amount of increase of velocity in equal interval of time is not same. Right? So in every 1 second, the velocity changes in a different way. Sometimes it is 5, sometimes it is 15, sometimes it is 20, sometimes it is again 10, like that. So such acceleration is called variable acceleration. When the acceleration of a body is variable, then every time the acceleration is changing. So we cannot say that this is the acceleration of the body. Commonly, we cannot say the acceleration of the body in the whole journey is equal to this particular value. We cannot say, because every instant the acceleration is changing. In that situation, we will calculate average velocity, right? Average velocity means total change in velocity divided by total time. That is going to be A average. A average is equal to what? Total change in velocity divided by total time. Total time. This can be next to delta V by delta T also. Delta V by this letter delta V, that is change in velocity, a small change in velocity divided by small change in time. This is called average acceleration. Average acceleration is equal to total change in velocity divided by or change in velocity divided by time. Am I correct? Okay. Sometimes instead of average acceleration, we will calculate instantaneous acceleration. Instantaneous acceleration means at that particular point of time when you watch the moving body, what is the acceleration of the body? That is what is called instantaneous acceleration. The instantaneous acceleration is given by vector A is equal to, that means this will come given as equal to dv by dt. dv by dt means a very small change in velocity due to very small change in time. This expression dv by dt, limit delta t tends to 0. Delta v by delta t is called dv by dt. So dv by dt means the differential coefficient of velocity, because differential coefficient of velocity everybody knows. I taught you that. Differential coefficient is the rate of change. In these situations, we can use differential coefficient as rate of change. Sometimes the differential coefficient is used as what is called a slope of a curve, a straight line, etc. For that also we can use differential coefficient. So differential coefficient is sometimes rate of change, sometimes slope. Slope is velocity only. In the case when the body is moving with uniform velocity, the graph is a straight line, right? Position time graph is a straight line. The slope of that is velocity, right? In a velocity time graph when we make, then slope of that is equal to acceleration. Slope is equal to dv by dt, because acceleration is the rate of change of velocity. Rate of change of velocity in the case when the graph is made, slope is equal to dv by dt. Slope dv by dt is equal to tan theta, that also we can find. So these are the things about instantaneous acceleration and average acceleration, etc. The unit of acceleration, that is meter per second square in the SI system. I mentioned only SI system, that's all, right? dv by dt can also be written as equal to, this is equal to, what I write, d by dt of v. But everybody knows that v is equal to what? Dx by dt. This here, dv is equal to dx by dt. What is dx by dt? Rate of change of position of a body, or rate of change of displacement. X is representing displacement or position, right? Okay. So change in displacement by time is called velocity. Dx by dt means rate of change of displacement. In place of v, you can put dx by dt also. Then what do we have? That is equal to d by dt of what? Dx by dt. This is d square x divided by dt square. See how it is read. D square x by dt square. You can write acceleration A is equal to dv by dt, or acceleration A is equal to d square x by dt square. Okay. This is the condition. Because dx by dt again differentiated. That means dx by dt is again differentiated. You will get d square x by dt square. What is d square x by dt square? This is called acceleration. Next, the equations of linear motion of a body moving with a uniform acceleration. So the equation of a body moving with uniform velocity you have already seen. That is xt is equal to x0 plus v into t. Uniform velocity motion equation, already you know, that has been taught to you. What is that? That is xt is equal to x0 plus v into t. So this relation already you have been told, that xt. Xt means the displacement or position of a body when time is t second. That is equal to x0. X0 means the position of the body when the time was 0 second, plus v into t. What is v? The body is moving uniform velocity. So this is the expression for a body moving with uniform velocity, or equation of linear motion of a body moving with a uniform velocity is given by xt is equal to x0 plus vt. Sometimes in place of xt, we can write simply x also. I wrote xt because the displacement or position of the body when time is t seconds, right? And this is x0. X0 means you are actually standing in a place, and a straight line is starting from your position, and that is x-axis or y-axis is the axis, all right? When you are standing at the body, at the origin, and look at the body was not exactly at the origin, but away from the origin, from where only you start watching the moving body. That means means that time when you watch the body, the time is given by t is equal to 0 seconds. At the time t is equal to 0 seconds, where was the body on the line along the x-axis or along the y-axis? That time, if it is x-axis you have taken, the body was at a distance x0. That means at the time t is equal to 0 seconds, the position of the body along the x-axis was x0. That may be 5 centimeter, 5 meter, 10 meter, 10 centimeter, any value. That depends on, you have to measure it. So when you just open the eye and you watch the body starting from a point, from where it is starting from the origin, that is equal to x0. Time t is equal to 0, right? X t is at the time. After that, the body is moving. When the time is equal to t second, what is the total distance traveled with the body from the origin to the time when t is equal to t second? This is x, and v is the uniform velocity. So today this is yesterday's portion. Already we have explained this one. Today we are explaining you what's a uniform accelerated motion. In uniform accelerated motion, I told you that acceleration always remains a constant. There are many relations there. One relation is v is equal to u plus at. Other relation is v square is equal to u square plus 2as, right? And another relation is s is equal to ut plus half at square, etc. Right? All this very simple mathematical method. Also, we can use to prove this one, or use to derive this one, or we can now about differentiation, integration, etc. That has been taught to you. We need only simple formulae to apply it. That's all. So, what all things you need, that has been taught to you.